Now, if we take a look at sales report number 2, what this allows us to do is handle the exception clause and continue on. So if you notice, what we've done is this one is pretty much the same as sales report number 1, except this time we've actually put a while a try-catch right inside of the while statement. We've also put a while around we're actually reading the file. Except this time we are calling it an open file. We've created an open file method. So if we come down here to the open file method, here we can see we've got a try statement inside of there. And what we're saying is, if we type in a file name and that file's not found, we go ahead and set the scan object, we set that to null, and we return that. Okay, so that if we try to basically do this input.hasNext, we're going to basically capture that error again as well. So here we have a try statement side of here, and we have if there. Okay, so let's say we're reading records from this file. We read a record, and we have a record that is bad. Well, instead of blowing up and stopping the whole program, why don't we just skip that record and continue on? So basically, here's what we've done is, if we have a mismatch exception, we go ahead and input file next line. We go ahead and read the next line and continue on. So if we take a look at the sales data.txt, I've actually entered some letters in there so that it's non-numeric data. So if I go ahead and run this, and non-numeric data was found, the invalid record will be skipped. Click OK. Non-numeric data was found. Continue on, and there we go. So as you see, we had a couple of instances. Apparently I missed the one. Yep, there's the A in there. So if I go ahead and make that back to a 2, again, so it caught twice, so I was able to still continue on and read those records and not blow up and not stop. So again, if I go ahead and have nothing but numeric data in there now and I run this, it basically ran just fine and life is good. But it still ran fine the other way, but it let us know that there was some bad data in there. So again, a nice way to capture the error, display it, but continue executing and not stop the process going. Now, this is a website that has just a small example of some different exception types that are out there. But we basically have 2 different types of exceptions. We have what are called checked and unchecked. Checked exceptions are those exceptions that are caused by the user. The user typed in something wrong. They typed in they basically did something. And unchecked are those kinds that we can basically kind of call them average, everyday exceptions that are out there. So here we have some unchecked, like arithmetic exception, such as divide by 0, array index out of bounds, array store exception, class cast. So you can see there's a whole bunch of different type of exceptions. And here's some checked exceptions. Again, these are caused by the user. Class not found, clone not supported, illegal access, security, all kinds of different types of exceptions that we can capture as well. So, okay, this next error is what is called a stack trace. And what we have, let me just give you the example. Here's the example. So we have the void main, that's the main method, and it calls the my method. And then inside of the my method, it calls the produce error. So what we have now is a method calling another method. That's called the call stack. So it's basically think of it as the process, the steps of this method calling that method calling that method. So what we have then is a stack trace. Then is that list. So that is the list of the methods being called in the order of the process. Well, we can have what's called a stack trace error. And a stack trace then will basically show us the steps of what was called and who called it. So let's just run it so you can kind of see what the error is. So here it is. So So whenever we see stack trace, know that we have a method calling a method, calling a method, calling a method, calling a method. So it could be one method calling another, or it could be a whole series of methods. So here we have stack trace at Java 35, which is the produce error. So again, we kind of work backwards. Here's where the error happened, and then it was basically, we can see that my method called the produce error, so we're basically working backwards, and the main called my method. So whenever we see stack trace, we know that we have a method calling a method, and basically a series of what those methods are doing, calling each other. Another way to catch these exceptions is basically having multiple in one statement. So here we have our try, and we're basically doing an open, and then we have a while loop, and then I have my catch. I can catch either a file not found exception or an input mismatch exception. If it finds one or the other, it will throw it into this object called EX, and there we can go ahead and then print some type of error. We can actually use the ex.get method. We could actually do that as well. We could say sys and we could say ex.get message, and basically let's see what prints out when we do that. So if we go ahead and run this, it says error. So error processing the file, and then we basically apparently we get a null message. And probably the reason we get a null message is because it's two different flavors of errors there, and if both of those errors catch, which one do we basically process? So if we want to use the get message, we have to have a specific exception that we are capturing. So what if we have a situation where we have an exception that isn't one of the standard API exceptions? Basically, we want to have our own exception that we can throw. Well, what we can do is we can basically do that, but we would have to use the throw statement. So the way we do that is we say throw new exception type and then some type of message string. And the example we have down here is throw a new exception out of fuel. So how do we capture that? Well, here's an example. We've got the date component string date, so we got basically a string date. If the date string is equal to null, we throw a new illegal argument exception, null reference passed to the date component constructor. Okay, so we've created a new exception just for that particular item. So we're saying, now you'll notice one thing we have here is we have an if statement. We're saying if there is some type of error. So we have to know the error. We have to have an if statement capture it. And that's when we say throw this new exception, and it will go through the whole entire process. Now, what is this illegal argument exception? That's a class or it's a method. So we have to capture that and basically So it says here the constructor throws an illegal argument exception if the date string parameter is null. The message null reference passed to a date component constructor is passed to the exception object's constructor. When we catch this exception, we can retrieve the message by calling the object's get message method. Okay, so let's take a look. Okay, so let's see an example of how we can do this. So here we have our main account test. This is basically got the main. This is where everything's going to start. And we have try bank account. So we're basically instantiating a brand new bank account called account, and we're throwing in a -100 in there. And we catch negative starting balance E, and we go ahead and say system out e.get message. Okay, what is this negative starting balance? Is that in one of the APIs? Probably not, since it has the word starting balance in there. There's probably not going to be that many starting balances that we're going to base some banking program. So if we look, we see that we do have a class called a negative starting balance. So if we take a look at that, let's see how it looks. It says public class negative starting balance extends exception. So it basically is bringing in all of the exception stuff because we are basically extending it. So exception is now the superclass, and negative starting balance is now the subclass. So we have this negative starting balance, which is the constructor, and we say super error negative starting balance. So we basically are calling the exception constructor. We're calling that constructor and passing in the string error negative balance. And then I've got negative starting balance again, which is the well, it looks like we've overloaded the constructor, and we have the double an amount, and we say super error negative starting balance plus the amount. Okay, so again, it looks like the constructor for an exception handles strings, and here we are throwing in the error negative starting balance, and then we're adding the amount. So we're actually converting the amount double into a string and passing it into this negative starting balance, which is basically being passed into the super. And then if we go back to the amount test, when I say e.getMessage, wow, do we have a get message over here? No, there is no get message, but where's the get message? It's here in the exception. Okay, which is perfectly acceptable, because we can grab this get message, because think of it, when we extend, think of all of that data from the exception class being brought into our negative starting balance class. So now when I come over here and I say e.getMessage, what's it going to display? Well, it's going to display one or the other. It's going to display error negative starting balance, or if we've passed in a double amount, error negative starting balance, one or the other. So if we go ahead and run this, and again, we've got a bank account over here. So here's a bank account. I think we've seen that before in some other program. So if I go ahead and run this, it comes up and says error negative starting balance negative 100. So since we passed in this numeric data, it went ahead and displayed this message as opposed to this one. So if we pass in nothing, this message will be displayed as opposed to this one, because it's overloaded. One last thing I'd like to cover is the finally clause, and the finally clause is part of the try catch. So we can have try something, if there's an error, let's catch it, and then we have finally. Now, the finally part of the try catch is always going to be ran. So here we have a situation where we try opening a file, we try to read that file. If we have an input mismatch, we do this, and we basically say the data is not found. Well, what are we going to do at that point? Well, at this point, finally, if we get an error, so if we get an error, we go ahead and close that file. Okay. Now, when I say it always executes, I should say it always executes if there's a catch. Okay. And so think of the finally piece of the try catch as a way to clean up stuff in order to, for example, if the user types something in wrong and that data gets put into this variable, if we have an error, we can go into the finally clause, clean up that variable, and then give the process back to the user and let them try again. And so that way there, we don't blow up the program. We can clean things up and kind of start the process all over again. Maybe we were building some type of an array. Well, instead of blowing up the program right there, we can go ahead and basically kill the array, stop it, go ahead and recreate the array, starting at, say, element 0, and then let them basically step through that whole process again, as opposed to, hey, what do we pick up from here? We don't know. So the finally statement is a great thing to basically clean up before we continue on. Okay, so that's all we're going to cover in Chapter 11. We just wanted to cover the exception process, and basically, so we're basically done. Had a great semester, and we'll basically see you down the road.